Hi everyone, I hope you're doing well. So in this video, we're going to discuss Geeks or Geeks problem of the day, and today's problem is game of XOR, and it is a medium level problem. So the problem says that we have been given an array of size n, and we have to find out the value of bitwise XOR of all subarrays of A, and then take the XOR of all of these values. Right. So this is the whole question. So for example, here you see that this is the array 1, 2, and 3. Right. So we have to consider all the subarrays of this particular array, that is 1, 1, 2, 2, 3, 1, 2, 3, 2 and 3. Right. Now when we have considered all of these subarrays, we have to take the XOR of all of these subarrays. So for example, this is the XOR of the first subarray, and this is the XOR of the second subarray, this is the XOR of the third subarray, right, and so on. Right. Now after we have taken all of the XORs, we have to take the final XOR of all of these values. So this problem is a bit of an observational problem, and let me just write down one more thing, that if you are writing the XOR separately like this, you can also write it like 1 XOR 1 XOR 2 XOR 2 XOR 3 XOR 1 XOR 2 XOR 3 2 XOR 3, right. So you can also write it like this. So basically I've done nothing, I've just written all the subarrays together, right. So what they were essentially doing is they were calculating the XOR of the subarrays first, and then taking all of these values and then again doing the XOR. But you can also write it like this, you can just write down all the subarrays and take the XOR together. Now our question is, what will be the contribution of each digit or each value in this particular final value, right. So as you can see that 1 is present here, and then here, and then here, right. So similarly 2 is present here and here. Let me just mark it with other color. So let's say 2 is here, here, and at 4 places, right. Since the frequency of 2 is 4, you will realize they can always exist in pairs. For example, this particular 2 will cancel out this particular 2. We already know the property of XOR, that A XOR A is going to be 0, right. So similarly in this particular case, 2 XOR 2, this is going to be 0. So let's say this value becomes 0, right. Similarly, these two are going to be 0, right. Now let us talk about 3. So we have 1 3 here, we have 1 3 here, and 1 3 here. So for both 1 and 3, the frequency is odd. So let's say that these two ones cancel out each other, and these two threes cancel out each other, so they become 0. The only thing that we are left with is 1 XOR 3, and that is 2 actually, which is the final answer of this particular problem. But the thing that I want to say is that all the pairs that are going to exist in this particular XOR value are going to cancel each other out, and only the elements with the frequency that is odd will be remaining in the final XOR, right. So this is the very first thing about this problem. Now the problem simply reduces to what are all the numbers for which the frequency is going to be odd, so that we can take them in the final array or in the final XOR value, right. For that, let us consider an example. So let's say we have 1 2 3 4 5 and 6. So this is our array, let's say, and I'm just going to write all the subarrays for this particular array. So let's say we have something here, and let's say that is 1, and let's say this next subarray is 1 and 2, 1 2 3, 1 2 3 4, 1 2 3 4 5 6. Yep, that's it. So these will be all the subarrays for starting from 1. Let me space them out a little bit. Okay, so I'm just spacing them out so that you can see them like a little more clearly. So now you see that these are all the subarrays starting from 1, right. Now what will be all the subarrays starting from 2? That will be 2, and then 2 3, and then 2 3 4, and then 2 3 4 5 and 6. But you can actually see that all of these subarrays have already been considered here, so you can see them here, right. What will be all the subarrays that are starting from 3? those will be these ones, right? What will be all the subarrays that will be starting from 4? These are all the subarrays. Starting from 5 will be this one, 5, 6. So actually I have missed one line. There should be one more line in between here. That should be 1, 2, 3, 4, 5. Right. So you see that all the subarrays are present actually in this particular single figure only. And let me just complete it also. 2, 3, 4, 5. Right. Now you see this figure is complete. So now what I can do is I have to count the number of ones, right, in the subarrays that are starting from 1. So those will be these ones, right? So there are actually 6 ones that start. So total frequency of 1 is going to be 6, right? Now the total frequency of 2 in the subarrays that started from 1 was 5. The total frequency of the subarrays the total frequency of 3 in the subarrays that started from 1 was equals to 4. The total frequency of 4 in the subarrays that started from 1 is going to be 3. The total frequency of 5 in the subarrays that started from 1 is going to be 2, and then for 6 it is going to be 1. Right. So this is the frequency of all the elements currently when we count the subarrays starting from 1. Now what will be the change when I start counting for all the subarrays starting from 2, then starting from 3, then starting from 4, then starting from 5, and then starting from 6, right? So you see that this 6 will again be present in all the subarrays starting from 1, then 2, then 3, then 4, and then 5 and 6 as well, right? So it was present in a total of 6 times. That is why I multiplied by 6, right? Now again let us consider for 5. So these two 5 which I counted for all the subarrays that started from 1 will be present in the subarrays that start from 2, start from 3, start from 4, start from 5 as well. So that is why I am going to multiply it by 5. So you see I am not directly counting it. I am just assuming that these will be the only two 5s that will be present in all these subarrays, right? That is why I showed you that all the subarrays can be from this particular triangle only, right? Those are all present inside this only. That is why I showed you that particular thing first. Now it is very easy to understand. Let's say for this particular 4, we know that there were 3 4s that were present in the subarray starting from 1. But the same 3 4s will also be present when the subarray starts from 2, or the subarray starts from 3, or the subarray starts from 4, right? So there will be a total of 1, 2, 3, 4. There will be a total of 4 times when these 4s will be present, right? Now similarly here I can write 3, then 2, and then 1, right? Now let's say for the first, this particular one, it will only be present when the subarray starts from 1. When it starts from 2, these one will not be present, hence it is 1 here only. So you see this is basically nothing, just the counting in reverse order, 6, 5, 4, 3, 2, 1 going right here, and then 1, 2, 3, 5, 6 going right up here, right? So I want that this frequency, that this final value that I get is odd, right? Only then this item or this value will be eligible to take because its frequency is odd. How do I make sure that the multiplication of two numbers is odd? It is only possible when both of the numbers are odd, right? Even if one of the numbers is even, that means the final multiplication is going to be even. So what I can basically do is, for each element at its position, I can check whether, let's say position I is starting from 1 and going till n, I can check whether I is odd and the value of n minus I plus 1 is odd as well or not, right? If both of the values are odd, that means I can take the correct value in my final XOR. So this was the whole idea of the problem. You just had to reach this particular conclusion, and after it the code is very simple. So let me just show you the final code. What I've done is I have initialized my answer with 0 and I'm just going through all the values. So I check, since this particular for loop starts from 0 and less than n, that is why I have to check for I plus 1 if this is odd, and I can check for n minus I if this is odd. If both of them are odd, I am going to take the XOR of this particular A of I into my answer, and at the end I can just return my answer value, and this would be the final solution of this particular problem. So let me just quickly submit this and show you that this particular code works and this solution is absolutely correct. So you see, it passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.